So today we're going to be looking at a 2019 question relating to circles. The question says CD and E are points on a circle. CE equals DE. The tangent at D is shown. ACD and BCE are straight lines, and you're asked to prove that y equals 3x. So the first thing we're going to do is use the alternate segment theorem to find DEC. Now you may be wondering, what is the alternate segment theorem? Well, the alternate segment theorem states that in a circle, the angle which lies between a chord and a tangent through any of the endpoints of the chord is equal to the angle in the alternate segment. So in this case, that is angle DEC. So DEC is 4x, as that is following the alternate segment theorem. Now the next step is identifying that DEC is an isosceles triangle. Now, from this information, we're then able to work out what the angle ECD is, and so we know that ECD and EDC are the same, and so that will be equal to the total angle of the triangle, which is 180 degrees. Take away the angle we know, which is 4x. So basically, ECD is 90, take 2x. And then from that, we're then able to work out what the angle ACB is, because using the vertically opposite angle rule, the two angles are vertically opposite, so ACB must also be 90 take 2x. Now from this, we now have all the angles needed to answer the question, so we want to prove that y equals 3x. We're going to do this by adding together all the angles in the ACB triangle and setting that equal to 180, as 180 is the total angle of a triangle, and so when we do that, it solves to y equals 3x, as can be seen on the screen. Thank you for watching, and if you'd like to see the mark scheme, here it is.